All right, welcome back. I hope you're having an amazing time so far. Our next speaker is Bryce Macher. He's a senior lead product analytics and science at CNN. Please join me in welcoming Bryce to our virtual stage.
Hi, everyone. Sorry about the slow delay there. My name is Bryce Macher, and I'm really excited to spend some time with you talking through the ways in which we've solved some of the 85% of DS projects fail problem in my team at CNN. You know, we all know the kind of talk and conversation about data science failing to prove its value over and over again. You know, we've seen this probably for the last 4 or 5 years, in fact. Everything from, you know, our top data and analytics predictions, including things like 80% of projects will remain kind of alchemy out there to wizards. Nobody's going to use it. 20% of analytics insights never deliver any kind of business outcome. Everything's stuck in pilot or prototype mode, never making it all the way to deployment. And so my talk today is really focused on how we overcome that, how we build teams, how we build organizations to focus on delivering business value. The big takeaway here is that the focus, whether we talk about individual tactics or bigger strategies, is really on data products. The data product approach, which is really about building internal products that deliver data to decision makers, whether they be business decision makers or customer decision makers, is the #1 way to prevent some of that data science failure. The 4 kind of strategies I want to talk about in my time with you. Data science starting at the moment of data strategy. We'll talk more about what that means, but essentially not waiting to hire your data scientists. It flies in the face of some of the things we hear as best practices, and I'll explain why I think that's a good idea to hire early when we get there. Second, building data science infrastructure for application, not experiments, is really key here to build the tooling that data scientists need to deliver data products rather than just experiments or data insights or one-time prototypes. Focusing on early growth applications of data science is crucial, and this growth means both in terms of business growth and in terms of data scientist growth. And then finally, hiring a data scientist who can do the science part of data science. We hear this pretty frequently, data science is this 3-legged table, and usually people avoid that math and statistics leg out of fear of it turning into a research laboratory or an experiment laboratory or a prototype only laboratory and really burning that business value. Instead, what I'm going to encourage you to do is lean into that 3rd leg there. So, starting with data strategy, a lot of the advice in the data science space is, hey, wait, build up your infrastructure, build up your data, build up your data ops infrastructure, and then hire your data scientist. But unfortunately, what ends up happening in doing that is because data science is a bit more of a newer practice in the IT and tech world. Because data science is a little more intense than, say, analytics, we end up with data strategy that doesn't account for the needs of data science. So data sourcing really matters to a data scientist. So putting a data scientist at that beginning stage, not an entire team per se, but a data scientist, is going to help you build out those requirements for origin point data. That is the most microbial level of data that a data scientist is going to need to build business value. What's that business value? We'll get there, but it's placing that strategy at the key or placing that data scientist at the key moment of data strategy is incredibly crucial. Data quality is probably the most important element of building out a successful data team. And having a data scientist there does a couple of things. First, it lets them think about the quality of the data they're going to need to make accurate predictions. If you're focused on business growth, if your goal is ultimately to, say, grow a subscriber base or to grow a customer base or to grow the amount of sales or time on site or impressions, well, knowing that you're growing is really crucial. And knowing that that growth is not just a figment of some kind of data problem is going to be very important to your data scientist, because if they're not thinking about data strategy or data quality, and they haven't been introduced to all of those data quality problems that have happened in the past, you're going to end up with data science tooling and data science solutions that just reproduce that history of data quality problems. On the other side, there are some really exciting tools in the data scientist tool belt to help think about data quality. If, let's say, you're bringing in traffic data, the tools that a data scientist has to know whether or not a day's worth of traffic looks normal or abnormal, if it's an outlier or part of the general trend that we've been watching, those will help you build automated data quality checks that data quality engineers may not be thinking about. So you also have a data scientist there to consult on things like statistical process control or other elements of the data quality pipeline. Finally, one of the biggest problems we see in data science is documentation. Not just documentation of code, that's its own ball of wax, but also the documentation of data. Data cataloging really matters. For a data scientist, that cataloging means two things. One, a centralized place to go and find the data they need at the correct level to be able to use and build, train, and make predictions. On the other hand, data scientists need to use data documentation. As a data scientist in an analytics team, I might be building data science solutions that generate a lot of data. It's going to a data mart. It's going to get consumed by other users. What is that data? What's the provenance of that data? What elements of your entire data mart or data architecture or data lake does that prediction rely on? Such that if, let's say, your traffic data is off, it would really throw off those predictions. Without documenting your data that's being generated by data scientists as inference or predictions, you run into a lot of risks in knowing about where data is coming from, the provenance, and some of that quality that may be a problem. So we have to think about data science as part of your data DNA. So rather than hiring it last as that little piece at the top of the pyramid, really thinking about data science as part of the data governance process. Now, if we're all being honest, we know that we don't start with data governance when we're building out our data environments. Most of us end up in places that started with data warehousing, or maybe that entire middle layer there at the top of warehousing, master data management, documentation. That's why it's so important to bring that data scientist in, is because you're not building that bottom of the pyramid at the start anyways. You're really starting with maybe some data architecture, maybe some data quality, but trying to find a solution to that data warehousing and putting that data scientist at the core of your data strategy, not as the center of it, not as the only person who drives it, but as a very key stakeholder, is going to supercharge your ability to build data science applications based on good data. It's also going to give your team, your data science team, a culture of thinking about data strategy, not just modeling strategy, not just prediction strategy, and not just business strategy, but also data strategy. Part of that strategy is thinking about building infrastructure for application and not just experiments. So if you leave out your data scientists from your data strategy, they're kind of out there on their own, building their own things, and they don't necessarily integrate with the entire ecosystem. That architecture that you build for data scientists is what will ultimately decide whether or not they're able to transform their experiments, their prototypes, their research into real business value via application. So there are a couple of things to think about here. Data science infrastructure cannot be local first. And what I mean by this is that you'd be amazed at the number of students that I've taught as a university professor, the number of students I've taught as an instructor of data science for places like General Assembly, the number of places even I've been or interviewed where data science starts on somebody's laptop. It's the first place they've got Anaconda installed and they're going to build some models. Starting with that micro level almost always sets you up for failure. Why? Well, because you're thinking about a model on a computer, not a model that's part of a giant data infrastructure and architecture that will ultimately return business value. So you have to start with the same cloud that will power your applications in order to ensure success. The other area that you need to move to is thinking about data science infrastructure as being primarily for both micro and macro deployment. And what I mean by this is that you can build projects for a single deployment point. That is, it's an ad hoc project. We just want to know this thing right now. Maybe we will, maybe we won't use this model again. That would be what I consider micro deployment. Use a low number of resources, but get that API out there, test it, run it, and then go ahead and decommission it. It's okay to decommission projects. Macro deployment, on the other hand, means we're building an application. We're going to go ahead and deploy our model in some kind of containerized technology. We're going to automate a workflow. We're going to automate the training, the testing, the validation. We'll automate the inference on the other side. We'll automate the modeling or the monitoring for our models. And we'll use that massive deployment as a way to build that data product. What building infra for both easy, lightweight deployment and these big application deployments does is it puts deployment and productization at the core of every data science project, not just a couple of them. Finally, data science infrastructure is not only technical, but it's also cultural. So making sure a good culture of experimentation exists is absolutely crucial. I don't want anybody to come away from the talk thinking I'm one of those data scientists who's like, no, don't explore, don't experiment, just build, build, build. I think experimentation is the most healthy part of a data science team. And the feeling that you can experiment and that feeling of fail fast is very crucial to success. And so making sure your infrastructure supports the full breadth of possible failures, whether it's on the model side or the deployment side, is very crucial to building a good data science culture that's focused on building infra for applications and not just experiments. What do I mean by that? Well, as you know, there's multiple different types of data science teams. You have machine learning engineering and product-focused data science teams that are building customer-facing products. You've got data science teams that are building primarily business applications and business products. Those requirements for deployment are very different. Making sure that you have an infrastructure that supports both as key to the data science workflow is going to help you overcome this problem. At CNN, I can tell you that, we're huge fans of Snowflake. There are a lot of tools in there, including the ability to connect to endpoints as user-defined functions, processed through other technologies like Airflow and dbt and Metaflow that we leverage on the regular basis to build products, data products that are data science focused. It also needs to make its way beyond a data mart, though. So as a team, I might build a model. I might process that model. I might build in some inference. I might write that inference to, back to our database, whether in Snowflake or Redshift or Athena or whatever other tooling you might be using. But ultimately, as a data scientist, I need to make sure that that information, those insights, can get delivered to decision makers, whether they're automated decision makers for prescriptive analytics or business decision makers for predictive analytics. So all that to say that it's not just about your internal AWS or Azure or GCP infrastructure. It's also about connecting data science products, those predictive, prescriptive analytics, to downstream consumers via your BI layers. And that takes a little extra engineering. If you don't put that at the core of your infrastructure, if you don't put it as an important piece of your data science technology, it might not become part of the culture. And if it doesn't become part of the culture, then you're going to end up with a lot of models that may be deployed. They might have these beautiful endpoints. They might write amazing predictions that are going to net the business a ton of money if people action off of them. But they won't make it to the place where they need to be in order to be actioned from. My third point, make growth and knowledge priority number one. And I mean this in two ways. First, growth and knowledge of your business. Grow your business, make knowledge about your business the priority number one for a data science team. The most important thing a data science team can do when they hit the ground is build up that growth and knowledge about who is actually the user or who is consuming this or who is visiting our site. On the other hand, growth and knowledge are really important to data scientists themselves. And so two pieces of advice here. Data science really is focused on reducing risk and optimizing opportunity. And so make those your key priorities. Build that in as your first product. What do we want the data scientists to do once our environment's up, once our infrastructure and tooling is good to go? We want them to focus on a project that is growth oriented or knowledge oriented. We want it to be able to tie to a real dollar value or a real understanding value that we can point to and say, this was the success for the team. That's going to set your data science team's culture in the right direction. On the second point, growth and knowledge at the data science level, one of the most important things I can see in data science strategy as I've participated in teams, as I've grown my own teams, is hiring in the middle. A lot of places make these mistakes where they want to hire a really advanced leader and they're going to work their way down from the EVP of data science to the VP to the director and then get those hands in there to think about what to do. Instead, think about it as an advanced middle and grow. Data scientist number one on your team is going to need to be senior enough to have seen it done before. They're going to be able to participate in data strategy conversations. They're going to know what pieces of infrastructure they need and how to stand up a lot of it. They might still need some help from your architecture team, but they're going to have done this enough times to say, I know what I need, I know how to connect, I need to build my model, and I need to start in on that business value. You want them to be senior enough to do that, to have their hands in the code recently, but not so senior that they've got a lot of great strategy experience, but not the ability to execute immediately. Once you've got that first project, that might be DS number one, it might be a team of 3, all kind of concentrated in that middle, promote, grow, and scale. Think about those first technical, tactical hires at that more senior level as that moment where you're going to make the decision between who might be a great IC in the future and who might be a great manager, whether that's at the manager level or even more of the strategic level of director. That DS team of 3 is defined by its wins. And this is one of the most important things to think about. That first project you land, the thing that everybody celebrates, goes out for dinner, back when we could have dinners together in person, the thing people talk about around the office for the next month, that's going to define the direction of your data science team. If that first big win is the delivery of an automated business capability that supercharges your growth, you're going to have a team that's really focused on building data products that supercharge growth. If that first win of the team is just a model, it's a prototype that shows that they could do this thing, and they can't quite get it to deployment because the infrastructure is not there, or they can't quite deploy it because the data strategy didn't really support this level of granularity and read-write access to data marts or the clients, well, then the team's going to be celebrating on the inside, but external, they'll be known as that team that almost delivered that thing, but we never heard from again. So making sure that we have an initial win focused on that growth is not only going to set our team in the right direction, but it's going to jumpstart what we call the flywheel of machine learning systems. Those data scientists are going to build great models that get served up by DevOps engineers and maybe internal engineers and handed off to product managers. It's going to get used a lot. It might be, a great way to grow your business by identifying key target audiences. It's going to get more usage. There's going to be more data. Data engineers might have to scale up some of that technology, and it's going to feed the data scientists themselves with new, more exciting, larger quantities of data. That might change their strategy for how they solve this problem. Upgrading that model to something that's more impactful, that brings more business, and that flywheel keeps spinning. When you do finally go to, moving to a different project or starting up another pod, that flywheel spinning is going to give some nice motion and direction to that new pod so that they too are thinking about, how do I scale up my capabilities so that you've got a flywheel of data scientists and a flywheel of data science capabilities. To that second point of growing teams, if we go all the way back to 2017, great article in Financial Times, Anthony Goldblum talks about part of the struggle that causes data scientists to be so frequently in flight. Some of those are a lack of clear questions. What are you trying to get the data scientists to do? Focusing on growth and saying, I need you to find the optimal way to grow our user base or to grow our purchases is a really high level enough question, with enough business value to get that team started. But to the second point, there's also a lack of technical knowledge among non-specialist engineers. So when you work your way down from that top, hiring your VP, your senior directors, your managers, and then finally hiring an individual contributor that now has, 4 bosses, it's very frustrating when they lack that technical knowledge. They were thinking strategically, they were doing the best they could, but because they weren't hands-on and thinking about how am I going to accomplish building this growth capability, it creates a lot of drag and a lot of frustration that causes a lot of shifting. No one needs to be reminded here of the Stack Overflow Dev survey, where I think it was 20% of data scientists, whether they're on the analytics side or the ML engineering side, saying that they're actively looking for work at one time. That's 20%. 1 in 5 data scientists on your team is thinking about leaving. And part of that is the frustration that comes with not making data product focus key to your data science strategy. So the final point is one that obviously I don't have to beat the drum here, but that we see time and time again. It's that we need to hire data scientists. Those data scientists, they're not engineers and they're not analysts. Why? Well, I'm sure you've heard it a million times, but data science is not only machine learning. Data science encompasses using a lot of different tools in the advanced math and statistics category to solve business problems. When we conflate it with machine learning, or we think about data scientists as only building machine learning models or deploying machine learning solutions, we lose sight of the fact that machine learning isn't always the right solution to a problem. Secondly, providing opportunity requires providing expertise. So even if we want to hire those really promising engineers or those incredibly talented analysts, if we don't have the data scientist on the team or with the data science experience that's required, then those engineers and analysts bring in with them a lot of great engineering practices, a lot of great analytics thought, but not a lot of data science solutions that gain traction. What do I mean by that? Well, let me walk you through one example. So I'm at CNN, as a lot of you have heard, we've launched CNN Plus, a brand new, exciting direct consumer application. And let's say our business asks us a question. How would you decide the key driver of user registration on our new app, CNN Plus? User registration, of course, being a subscription, right? This is a subscription service. What are the key drivers of subscription? Well, data analyst is going to start with a regression analysis, time-tested technique. They're going to identify the key potential features that would make up independent variables of a user. They're going to look at everything about the user that we could possibly know, maybe some demographic information, maybe what device they're looking at the paywall on, maybe what they've looked at up until that point. We're going to build different kinds of aggregations, maybe quantify the amount of content they've consumed. Then we're going to build a linear regression. We'll check the p-values of each feature that we fed our model to make sure that they're relevant, that the relationship between those values is not just a product of chance, but is actually meaningful. And based on those values, we're going to take each of the coefficients in our linear regression. We're going to say, hey, as this value increases by X amount, Y increases, or the probability of registering increases by this much. That kind of analysis is going to give you some feedback. It's going to give you some direction, but the methodology is wrong for the problem. Remember, if we go back to our key driver of user registration, we're not asking for a continuous value key driver. Like if X increases, Y increases by what amount? What we're asking for is a probabilistic value. What's the probability that this user would register for our new app based on what we know about them? So a regression analysis, even if you use the right kind of regression, isn't going to solve this problem. So we might go to our data engineer, and our data engineer says, hey, you know what, this is an easy problem. I am a very product-focused engineer. So I'm going to build this out and really make a drive to build you a data product. They're going to grab a module, they're going to apply it, they're going to deploy it. They're going to have this really great data pipeline. And then they're going to go find some software that explains it for you, probably something like a Shapley value. And then based on the most valuable model for that, they're going to say, these are the most important. That actually doesn't tell you anything other than how well your prediction is generating predictions. Shapley values are a game-based approach to figuring out how good your prediction is, not how well your prediction corresponds to reality. That data scientist is going to reach deep into their statistics toolkit, and they're going to say, hey, you know what? I remember this trick question from a stats exam, and I'm going to use dominance analysis. So to wrap up there, 4 strategies for avoiding the fail in analytics, data science focused analytics. Think about data strategy, build infra for applications, focus on early growth, and hire a data scientist who can do the science of data science. And above all else, keep that product mindset in play. Data products are the way to data science success. Thank you.
Awesome. Thank you so much, Bryce. That was amazing. If you could stop sharing your screen, I know this audience wants to give you a huge virtual round of applause.
Thank you
so much for sharing these insights with us today. All right, for the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection request and take some time to check out our amazing exhibits. Thanks so much, and we'll see you around.